Good evening. Today we are going to see the relationship between stress strain in HYSD bar. Already in last video we have seen that is for mild steel we can find value directly by using this formula. FSC is equal to 701 minus DC upon XU less than or equal to 0.87 FY. Now for HYSD bar already we have mentioned in last, we cannot have any definite relation directly, or FSC and epsilon SC can be obtained because stress strain curve is not linear, and therefore we have to find values by using stress strain diagram for HYSD bar. Now you can see we have this was for FY 250, or we can say this mild steel because they have mentioned a definite yield point, and due to this we are going to calculate FSC that is equal to 700. We have already mentioned here 700 1 minus DC upon XU. So 700 in bracket 1 minus DC upon XU, and always keep in mind values in both cases should be less than or equal to 0.87 FY. So these all we have for your mild steel. We have here definite yield point. Now this diagram is given on page 70. Now we will go with this diagram. Now you can see this. Here values are given. We have 0.87 FY, sorry 0.8 FY. This is 0.8 FY, 0.9 FY, 0.9 FY, then 0.97 FY and FY. This FY actually, if you will see, we have this Fy upon 1.15. So we are going to use this diagram where we will get it as 0.87. Sorry, this we will get it as 0.87 Fy, which is Fy upon 1.15. And now we will go with this diagram, and by using this diagram we are going to calculate the values of stress and strain. Now this here clearly mentioned cold work deformed bar. So these are for HYSD bars. And now we will go with this. Again, diagram is on page 70. Now you can see this. We have these values. And now we are interested to find strain and stress. Now we will start with 0.8 Fy. You can see 0.8 Fy. Now 0.8 Fy, and we are going to get this. You can see this 0.8 Fy. We are going to get this value. That is going to be 0 over here. So now we will calculate it. So we will have this epsilon SC. So now we know stress upon modulus of elasticity. What is strain? Stress upon modulus of elasticity. And whatever these are given, these are inelastic strain. Now we are going to be total strain, if I will mention this. So we have elastic strain plus inelastic strain. Now whatever is shown in the diagram, this is inelastic strain, and elastic strain we can find directly by this. That is stress upon modulus of elasticity. This is elastic strain, and this we have taken from stress strain diagram, which is inelastic strain. Now 0.8 FYD upon ES plus 0, because for first value 0.8 FY, you can see we have this value as 0. And now we will go with this. We will substitute the values 0.8 into 0.87 into 415 upon 2 into 10 raised to 5. This value is 0. And from this we will get value of epsilon CS SC is 0.00144. And against this we have value of stress FSC, and that is equal to 0.8 into 0.87 into 415. And if we will see, then we have this value that is given over here 0.00144, and against this we have 288.7. So this is for 0.8 FYD. So we have to prepare the table for all, and that we are going to prepare over here. So We have first for 0.8 FYD. Now next we have that is 0.85 FYD. So now we will calculate for this epsilon SC 0.85 FYD upon ES. Now here we have actually 0.0001. This is inelastic strain. You can see this. So this is again elastic stress upon modulus of elasticity, and this is given in stress strain diagram, which is inelastic. And then from this we will put the values 0.85 plus 0.87 FYD. We have 0.87 into FY plus 0.001, and we will get this value that is equal to 0.00163. And FSC in this case we will have 0.85 into 0.87 into 415. And likewise we have to go for this. Now if we will go to 0.9 FY, then for 0.9 FY you have inelastic strain as 0.0003. 0.9 FY your elastic strain is 0.0007. You can calculate and check it. Then we have for 0.95 we have this elastic strain is 0.001, and for FY we have elastic strain as 0.002, because you can see we have marked this line, and this line we have taken parallel to 0.2% of proof strain, and from this we are going to get these values of FSC, and same we have to use for both, that is FY 415 and FY 500. And you can see in this next table, so how to calculate elastic strain plus inelastic strain, that we know now. And we have, this is the table for FE 415, FE 500, and you require this table to solve the problem in examination. So we should know how we have to calculate these values. So for 0.85 FYD we have already seen this, then 0.9 FYD, then we have 0.95 FYD, then we have 0.97 FYD, and then we have 1 FYD. And similarly we have these values, and then from this we are in position to calculate the values. And elastic strain we have seen that for 0.8 FYD we have elastic strain, you can write here 0.0000, then here we will get 0.0001, here we will get 0.0003, then here we will get 0.0007, and then here we have 0.001, and here we have 0.002. So directly you can add this in this respective for FE 500. Here you can see these values whatever we have written over here, that values, all values are given 0.00137, 0.001 and 0.002, and that we have shown over here. Means you need not require to keep in mind, or you need not require to go for the curve, just to keep in mind these values, that is 0.000 first value, 0.00137, then 0.001, and then we have 0.002. So these values we have to add, we have to divide it by ES. So this will give me elastic strain, and add this inelastic strain. So you will get value of stress. Now you have to calculate. Tomorrow in the class we are going to see how we are going to get these values for FY 500. So likewise we have to calculate the stresses, and now we will stop over here for this calculation of stresses which we require for design and analysis of the doubly reinforced section. So thank you.